Hi everyone, this is lesson 5, Friday, December 5. First thing we talked about was a slight review, a little review of strings in the context of string interpolation. I told you in previous classes that the double quote and single quotes are completely equivalent to each other, but that's actually not always exactly true. So let's get into IRB and let's actually compare how things differ for string interpolation. Let's say that I have a variable x that contains a number 18. And I actually want to use string interpolation to print it on the screen, so I'm going to do a puts, double quote, and say the number is # curly brackets x. And as you would expect, it says the number is 18. This actually only works with double quotes. If you use single quotes to do exactly the same thing as I'm demonstrating right now, what you will get actually is the number is # curly bracket x. So in that case, in the case of single quotes, you're not getting an evaluation of the variable x as part of the string. So if you're doing string interpolation, you have to use double quotes. The new topic for today is this new data type that we talked about, which is booleans. So we know about floats, we know about integers, we know about strings. So now we have a new type called a boolean. So what's going on with booleans? So in the case of a boolean, you can actually have only two values. The values are true and false, and you actually use these values literally by typing the word true and the word false. So I can create a variable named flag, and I can give it the value of true, and I can also give it a value of false. And that's really all there is to actually the Boolean data type. I should mention the fact that because true and false are these reserved values in Ruby, you really can't use the words true and false as names of variables, as labels on a box if you want. So if I were to actually say true equals 1, then Ruby would complain in saying I can't assign the value 1 to true because true is really a reserved keyword. But what can you do with these booleans? Basically, if you can just assign them to true and false, you really can't do much that's interesting. So booleans become useful when you start actually pairing them with operators and some of the logical operators that we can use to do comparisons. So the basic rule is this: if you try to compare two numbers, you're going to get a result which is a boolean. So if I say 3 is less than 4 in Ruby, the answer is a boolean, true. And if I do 3 is greater than 4, I will get a boolean, which is the value of false. So that's really in that context that the booleans really become most useful to us. Notice that Ruby is smart enough to deal with floats and integers in the same expression. So if I say 1.0 is less than 2, it does not complain that one number is a float and the other an integer. It will actually correctly decide that 1.0 is less than 2. What if I actually want to compare two numbers with a less or equal or greater than equal? How do I type those? So in Ruby, the way you would do that is you would say 3 is less than equal by literally typing the two symbols next to each other. 4, it would be true. I could do 4 less or equal to 4, and it would of course be true. And similarly, I can do 5 is greater than, and then the equal sign after, always to the right of the comparison symbol, 4, and it will say true. So this basically begs the question as to exactly how are we going to actually compare whether two numbers are equal to each other or not, because that's actually tricky given the fact that we've seen that the single equal sign is actually the assignment operator. So if I were to say 4 equals 5, that actually doesn't work. We even get an error because Ruby at that point is trying to assign the value 5 to the number 4, and 4 is not a valid variable name. So the answer is, the way you deal with that is that you have to use a double equal sign. So it's 4 equal 5. So this is something we don't see in math, we really just see that in computer science. 4 equals 5 is false, 5 equals 5 is of course true. And the last one of those comparison operators we want to learn today is how to say that something is different from something else. And the answer to that is that you use actually the symbol exclamation point and equal to say that two numbers are different from each other. So a couple of things to note. Note that 2 and 2.0 are exactly the same thing in Ruby. Yes, they are of different types, but Ruby is smart enough that if you say 2 equals 2.0, it will say true even though they are different types. And also be very careful with the double equal and the single equal. I would say that the error of using a single equal when you should use a double equal is probably the most common mistake people make in programming, whether they're experienced or not. Okay, how can you use these comparison operators outside of numbers? Well, you can actually use them also with strings, because Ruby understands lexicographical order. So if I said, is the letter A less than the letter B, it will actually say true because it knows that A comes before B. You can do that with longer strings. So if I said that ABCD is less than BCDE, it would say true. But even better, I could say ABCD is less than ABCE, and actually it would know that the first 3 characters of the strings are the same, but it would find the difference at the 4th character and correctly tell me that ABCD comes before ABCE. I should point out also that in this case, uppercase characters are different from lowercase characters. So if you try to do capital A less than lowercase a, it will say true. If I say capital A equals little a, it will say false. So be careful when you're comparing strings with each other, that sometimes what you want to do is you want to make sure that they're all uppercase or all lowercase before you can truly compare them. So I could do something like this. Capital A dot downcase equals little a, and then you will say true, because capital A dot downcase will give me a lowercase a. Can I compare booleans with each other? Absolutely. True equals false would give me false, and then true different from false should give me true. On the other hand, the concept of saying that true is less than false is meaningless. That's really not something that we deal with. Okay, so after looking at comparison operators, we started looking at conditionals and really starting to write some intelligence into our programs by adding what we call the if statement. So let's take a look at that now. So to test out how conditionals work, we're actually going to go write a program. So we're not going to go into IRB. We're going to create a new file, which we will call con.rb. And we're going to start experimenting with that. So the first thing we're going to do here is we're going to say grade is equal to gets.chomp.2i, like we've done before. So we're getting a number from the user. And then what we want to do here is that we actually want to print on screen some information based on whether the grade is a passing grade, a failing grade to start with, and then we will talk about how we add complexity to that. So the idea of an if statement is that it's a branching condition in your code. It's a way of adding intelligence to your code so that based on the user input, you're able actually to make a decision and tell your program what to do in either or both cases. So in this case, what we want to do is that we want to say if grade is greater or equal to 60. So notice that on the line next to the if, the expression grade greater or equal to 60, this is a comparison that we'll evaluate as a Boolean. That's very important. What's to the right of the if should always be a Boolean once it's evaluated by Ruby. Notice that when I press enter, Ruby automatically gives me an indent, and that's to help me both visually line up and understand that I'm actually now writing code that corresponds to what happens when the if statement is true. The first part of the if statement is always when it's true. So if the grade is greater or equal to 60, I will say puts pass, and then I want to actually create a second branch, and the second branch would be what happens if the grade is not greater or equal to 60. And so I use the keyword else, which basically opens a second block of code in which I can say fail. In the case of an if statement, I should always have an end keyword to finish the block. So you can see now, this is the true part right here, and this is the false part right here. If I want to add additional complexity, I can actually put another if inside of an if. So in this case, I might decide that I want to know not just whether the student is passing, but whether the student got an honors grade. So inside of the block that says that we're passing, I can actually add another if statement that says if the grade is greater or equal to 85, notice the additional indent under that block. So this is the true part of that statement, where we would say this is honors. And then the else part of that statement would be what happens if the grade is greater or equal to 60, but not greater or equal to 85, which is a normal pass. And once again, I need to end that if statement, that if block, with an end. Once I'm done with that, I should be able to execute this code, enter a grade, so 83, and it tells me it's a pass. If I enter a grade of 59, it's a fail. If I enter a grade of 93, it's honors. And that concludes lesson 5.